Right, on to section 1.4, rewriting equations and formulas. Solve each equation for the indicated variable. Where's this going to come in handy? Well, one, whenever you're graphing lines, if you have something that's not in slope-intercept form already, it could come in handy, unless you want to deal with, just dealing with the intercepts. If you have a formula, for instance, let's say for interest, but you're not trying to find the interest, you're trying to find out what the time was or what the rate was of it. You need to be able to solve for that portion. Those things come in handy, so it's something we're going to take a look at here. Solving for y, hopefully you've been doing this for a while. Okay, we're trying to get that by itself, so whatever's not in my box, the 7x, we need to move to the other side. Well, since it's being added here, we have to subtract it to both sides. And then divide by -3. And you may say, now do I need to write each one as an individual fraction? That's up to you. Since we're not graphing the lines right now, if you wanted to leave it in that form, you could. Or you could write it this way. Okay? Either one of those would be acceptable. Make sure my negative shows up here good. But again, either one works. Solving for time. I'm multiplying all these together. What's the opposite or the inverse of multiplying? Well, it's dividing. So we'll divide both sides by the p and the r. And you'll notice that most of these don't take that long. But always look to see what you're working with. Again, solving for x. My x term needs to be isolated first. Add the 9y over. Divide by 11. Again, if you want to leave it in the fractional form like we did over here, you can. If you want to leave it in a singular fraction, that's fine too. The last interesting one. Solve for y. You're like, but I got two things that have y. Can I just, minus the xy over and divide by -1? I have y. Right, but I can't have y as part of my answer if I'm trying to solve for it. So I notice both of these have a y. So I'm going to go ahead and pull that common factor out. What's left? Y times what gets me to xy? X. Y times what gets me to -y? -1. Now I can work with it. Now I only have a singular y. And since I'm multiplying it by the x minus 1, what's that opposite going to be? Well, to divide by that. And I get to my solution. So when you're doing these, you cannot have the variable that you're solving for as part of your answer. So sometimes a lot of thinking is going to become involved here with just getting that y on its own. Okay, a little bit of manipulating. Find the value of y for the given variables. Now again, you have options. Here, I could plug the -1 in right away for x and then just solve for y. Or maybe I want to solve for y first. So I'd subtract the 3 over, and I'd divide by 2. And once I get to here, then I would plug my number back in. Say, Harty. One moment, please. Slight interruption. Now that we're back, I notice we have a brain cramp here. Where did my brain cramp occur? It's back in my first one because I should be getting the same answer here. Yeah, went too fast. That's exactly it. You're like, Harty, since when is -1 minus 3 -2? Since I was doing my own special math, that's what. So subtract the 3 over, that's -4, and divide. Okay, now we're getting the same answer. But again, even on one of these, if you're not asked to, it's a good idea to kind of get in the habit of taking that y out. Here, if I plug that -4 in, making sure I don't do anything cuckoo again, -4 minus 1 is -5y, and divide by the -5. Okay? So again, just be careful, unlike what I was doing when I came back over here. Sometimes the simplest things can be the hardest if you try to go too fast. Okay, writing an equation with more than one variable. We're doing a benefit concert. We have two types of tickets, adults and children. Write an equation with more than one variable that represents the revenue from the concert. Okay, I have adult tickets. We're going to get creative here. We're going to call that A. We have child tickets. Again, getting uber creative. We're going with C. And then we're going to have some revenue. We're going to call that R. So let's see. Think about it as we would normally in words. You'd have your adults plus your children equals your revenue. And I'm just doing it on this first one so you can see how simple this is going to be. I don't have any values to work with. Prices of tickets, number of tickets, or anything. So all I can do is say my adults plus my children equals my revenue. That's all as further I can go. Okay, it's taking something abstract, making it something a little more real. Now let's get some values involved. For the concert in example 3, our goal is to sell $25,000 in tickets. We're going to charge $25.25 for an adult and expect to sell 800 of those. You need to determine what to charge for child tickets. Okay, so if we take this as our guide, adults, we have $25.25 and we're going to sell 800. Price times quantity. Plus our child tickets, and we want to sell 25,000. So I'll go ahead and multiply this out. Subtract my 20,200 over. Left out the number of my child tickets. That's kind of important. 200C is going to be 4,800. Divide by the 200. And I'd have to be charging about $24 for the child tickets. Now you're like, so I got to do that on all three of these? Not necessarily. Well, why would that be the case? I'm going to sell the same number and price of adult tickets every time. So that 20,200 that I got will be the same every time. The only thing that's going to be different is the amount of child tickets that I'm selling. So once you get that initial equation ready, it's not going to end up being that bad. Divide by 300. Now the tickets, it only cost $16 for a child. And you kind of get the idea. You're like, hey, it seems to be coming up at 4,800 every time. Could I just do 400C equals 4,800? Absolutely. And that's kind of the point we're trying to prove here. That once you take the time for the initial setup, if you do it correctly, it makes doing the other ones much simpler. And finally, down here at the bottom, lots of formulas that we might need are listed in the textbook, so it's good to know those and have a feel. So for example, the formula for the perimeter of a rectangle is P equals 2 plus 2W. Solve for W. So you're like, okay, so let's see. My perimeter, this kind of goes back to what we were doing up above, maybe in example 1 part D. If I'm solving for W, but I do have something that's in common, you're like, now why would you necessarily do that? Well, there's a couple of reasons why I might do that. Let's go ahead and solve this way. I'm going to divide by the 2. And I'll subtract the 1. Okay, that's one way I could go. Because some of you are like, well, the way I was thinking, why wouldn't I just, if I'm solving for W, let me rewrite it here. Why wouldn't I just subtract the 2 and then divide both sides by 2? And you could. Either one works. It just depends on how you're looking at it. And you're like, these are the same thing? Yeah, because here's P over 2. Okay, and negative 2 divided by 2 is negative 1. You've got the same idea. So good luck here. Again, we're trying to keep things, make you think a little bit on this, and get you prepared for some later units.